ಹಾಯ್ ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ವೆಲ್ಕಮ್ ಟು ಟೆಕ್ ಗರ್ಲ್ ಕನ್ನಡ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್. ಡೈನಮಿಕ್ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಅಂದರೆ ಏನು? DP is an algorithm design method that can be used when the solution to a problem may be viewed as a result of a sequence of decisions. ಅಂದರೆ ಒಂದಷ್ಟು ಡಿಸಿಷನ್ಗಳ ಮೇಲೆ ಅದರ ರಿಸಲ್ಟ್ ನಿಂತಿದೆ ಅಂತ. General method for optimizing multi-stage decision process. An optimal sequence of decisions may be found by making the decision one at a time and never making an errorless decision. In DP, an optimal sequence of decisions is arrived at by making explicit appeal to the principle of optimality. This principle states that an optimal sequence of decisions has the property that whatever the initial state and decisions are, the remaining decisions must constitute an optimal decision sequence with regard to the state resulting from the first decision. First decision in answer ಮೇಲೆ second decision ನಿಂತಿರುತ್ತೆ. Dynamic programming stands for planning and does not refers to computer programming. Knapsack problems. An optimal sequence of decisions will maximize the objection function. Knapsack problem is also called as maximization problem. Maximum weight ಕಂಡುಹಿಡಿಬೇಕು, ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಫಿಟ್ ಕಂಡುಹಿಡಿಬೇಕು. ಈ ಥರ ಮಾಡೋದಾಗ knapsack ಪ್ರಾಬ್ಲಮ್ನ ನಾವು ಉಪಯೋಗಿಸ್ತೀವಿ. ಮತ್ತು ಶಾರ್ಟೆಸ್ಟ್ ಪಾತ್ ಕಂಡುಹಿಡಿಯೋಕ್ಕೆ an optimal sequence of decision is one which results in the path of least length. In formulating the DP recurrence relation that has to be solved, one may use one of the two different approaches, forward or backward. Let x1, x2 to xn be the variable for which a sequence of decisions has to be made. In the forward approach, the formulation for decision xi is made in terms of optimal decision sequences. For xi plus 1 to xn, look ahead on the decision sequence x1 to xn. In the backward approach, the formulation for decision xi is in terms of optimal decision sequences for xi to xi minus 1. Look backwards on the decision sequence x1, x2, xn. Feature of the DP approach is that optimal solution to subproblems are retained so as to avoid the recomputing their values. All the optimal solution of the subproblems will also be retained in the graph so as to avoid recomputing it. DP is a technique for solving problems with overlapping subproblems. These subproblems arise when a recurrence relating a given problem solution to the solutions of its smaller subproblems rather than solving overlapping subproblems again and again. DP suggests solving each of the smaller subproblems only once, recording the results in the table. ಅದು ಎಲ್ಲ ಸಬ್ಪ್ರಾಬ್ಲಮ್ಸ್ನು ಒಂದು ಸಲ ಮಾತ್ರ ಸಾಲ್ವ್ ಮಾಡೋದು, ಅದರ ರಿಸಲ್ಟ್ಸ್ನ ಒಂದು ಟೇಬಲಲ್ಲಿ ಅದನ್ನು ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ. The original problem can be obtained. DP is typically applied for optimization problem. ಮಿನಿಮಮ್ ಮಾಡಬೇಕಾಗಿರೋದ್ರಿಂದ ಅಥವಾ ಮ್ಯಾಕ್ಸಿಮಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಉಪಯೋಗಿಸ್ತೀವಿ. Divide and conquer. First problem is divided into smaller subproblems. These subproblems are solved independently. Finally, all the solutions of the subproblems are collected together to get the solution to the given problem. Duplicate subsolutions may be obtained, less efficient because of rework on the solution. ಇವಾಗ ಒಂದೇ ಸೊಲ್ಯೂಷನ್ ಇನ್ನೊಂದ್ಸಲ ನೋಡೋದಕ್ಕೆ ಹೋಗುತ್ತೆ, ಅಗತ್ಯ ಇಲ್ಲ, ಒಂದ್ಸಲ ಮೊದಲೇ ನೋಡಿರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಒನ್ deficiency in this. Uses top-down approach problem solving, recursive ಮಾಡುತ್ತೆ. Splits is included into specific deterministic points, usually in the middle. Then dynamic programming, many decisions sequence are made, generated, and all the overlapping sub-instances are considered. Computing duplication in a solution is avoided totally efficient. Uses bottom-up approach of problem solving, which is iterative dynamic programming and divide and conquer ಗಿರೋ ಡಿಫ್ರೆನ್ಸ್ ಇದು. Splits its input at every position, splits point rather than the particular point. After trying all split point, it determine which split point is optimal. ಇದೇ ನಮ್ಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ ಡಿವೈಡ್ ಆ್ಯಂಡ್ ಕಾನ್ಕ್ವರ್ ಹಾಗೆ ಡಿ ಪಿಗೆ ಇರುವಂಥ ಡಿಫ್ರೆನ್ಸ್. ಗ್ರೀಡಿ ಮೆಥಡ್ ಆ್ಯಂಡ್ ಡೈನಮಿಕ್ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಏನು ಡಿಫ್ರೆನ್ಸ್ ಇದೆ? ಗ್ರೀಡಿ ಮೆಥಡ್ ಯೂಸ್ ಇಟ್ ಫಾರ್ obtaining optimum solution, set of feasible solutions, and pick up the optimum one solution. Optimal selection is without revising the previous generated solutions. There is no as such generated of getting optimum solution. Only one decision sequence is even generated. DP use it for obtaining optimum solution, but no special set of feasible solutions will be there. Consider all possible sequences in order to obtain the solution. It guarantees that it will generate optimal solution using principle of optimality. Many decision sequences may be generated. Both has different strategies, but the purpose is the same. DP is time consuming compared to the greedy method. Where it can be applied? It can be applied at nostalgic graph, all pairs of shortest path algorithms, knapsack problem, traveling salesman problem, optimal binary search tree, reliability design. DP uses two methods, that is memorization and tabular method. Memorization follow top-down approach, which is recursive. Tabular method follow bottom-up approach, which is iterative. For example, for Fibonacci we have int fib of int n. If n is less than or equal to 1, return n, or else return fib of n minus 2 plus fib of n minus 1. Then for this we have n equals to 1, Fibonacci of 4 will be Fibonacci of 3, Fibonacci of 2. Then for Fibonacci of 2 we have Fibonacci of 1 and 0, Fibonacci of 3 we have Fibonacci of 2, Fibonacci of 1. Then again to find considered 9 calls, that is 2 power n. Many times the same function is called again and again. Reduce the function calls and reduce the time taken. That is int Fibonacci of int n, int less than or equal to 1, return n. F of 0 equals to 0, f of 1 equals to 1. Then for int I equals to 2, I is less than or equal to n, I plus plus f of I equals to f of I minus 2 plus f of I minus 1. Like this it goes on, stores the result in the array. So the total 5 times it is called, and Fibonacci n is equals to n plus 1 calls will be taken. Finally it's done from smallest value. So it is the bottom-up approach, reducing the time complexity from 2 power n to n. Thank you for watching. Do like, share and subscribe to my channel.